Hi, today we are going to present about electricity circuit. Our group consists of Palm, number 2, Permagut, and Carnison from class 513. So firstly, the current. The current is the flow of electricity in a electronic circuit and to the amount of electricity flowing throughout the circuit. As you can see on the screen, this is a circuit, some kind of circuit. And this is the resistance is called a resistor, but it is used for the resistance, a measure of how difficult it is for the current to flow, measured in the units of ohm, and the amount of current is measured in the unit of amps. For the potential difference, is any 2 point in electric electric field is defined as the amount of work done in moving a unit positive charge without acceleration from one point to another along any path between 2 points. Here, as you can see, if I put these two, the voltage would be the same without change. So, for the formula, the, the current that related to charge and time is I equal Q T. T is for time and Q is for charge, where I is the current. So it is just Q divided by time equal current. And for this formula, the current I is in a circuit is defined as the rate at which change flow to a given point of the circuit over time. Where the next one is the current that relates to I equal NAVQ. For the I is the same as the current, N is the number of electron in meter squared in meter cube, and A is the cross sectional area, where V is the drift velocity in the material, and Q is charge of each carry in different material. Where the current I is macroscopic property of charge carry in the conductor. And lastly, for me, is Ohm law. Ohm law states that the voltage across a conductor is directly proportional to the current flowing it through the pro the the pro all physical condition and the temperature remain constant.
Hello, my name is Ganesh Onjiri number 24, class 513. Okay. Ammeter is a measuring device used to measure the electric current in a circuit, like this. Okay. And now, the voltmeter is used to measure the potential difference between 2 points in an electric circuit, like this. Okay. And now I'm gonna present about the voltage in terms of breakdown. The voltage in a term of work done in physics, voltage is an amount of work done per unit charge to move a charge between 2 points in an electric field. Now, conversation laws in the circuit charge, the total charge or current entering and junction in circuit equal the total charge of or circuit or current leaving the junction. Energy. The total energy gain per unit charge in a circuit equal the total energy lost per unit charge as it completes a loop. Power formula. Power is the rate at which energy is transferred or converted. And I'm gonna show the power formula. The power formula. This is a formula of power. And the last one, resistivity with formula. I'm gonna show you the resistivity formula. Resistivity. This is a formula of resistivity. Resistivity is a measure of how strange a material opposes the flow of electric current. Is an on flow of electric current is an electric property of and temperature.
So next I'm gonna talk about the special feature of the parallel circuit. So for the parallel circuit, if the two more part of current to flow through, as you can see in the simulation. So if we use the voltage meter to find the voltage, is gonna not split up and always the same in everywhere. So as you can see, it's gonna be 9 volt over here. Even from the start, it a 9 volt, and at the bottom is also 9 volt because the current, the voltage is not split up, but the current is split up during a branch. And the another special feature is the adding resistance to reduce an R. And next, I'm gonna talk about the resistance in series circuit. So in series circuits, when we adding more resistance, if we increasing the total R, the series circuit is the one at the bottom right, this one, and this one is the parallel circuit. And next is the resistance in parallel circuit. So when we adding more resistance, it will reducing the total R. And next is the change in temperature, is what happened when we change the temperature. So when increasing the temperature, it will make an atom in wire vibrate more and make electron difficult to flow. That will make resistance increase and current gonna go decrease. And next I'm gonna talk about what is ohmic conductor, filament bulb, thermistor, capacitor, and diode. So first I'm gonna start with the ohmic conductor. So an ohmic conductor is the something that let electricity to flow smoothly. If you push more electricity, voltage, or more flow, the current in a steady way. So for the example, it's gonna be the wire that made from copper. Next is the filament bulb. So filament bulb is just like a light bulb, but with a tiny wire inside. So when we put a lot of electricity, if go through the wire, it will get very hot and glow to make a light. And next I'm gonna talk about the thermistor. Thermistor is a tiny part that change how electricity flow depending on the temperature. It is used to measure heat or control temperature in device. So if overheat, it will make the device go colder. And next is a capacitor. Like as you see in the picture, a capacitor is a small device that store electricity for a short term. It can relieve the stored energy when needed, like like some kind of a battery, but it relieves the electricity faster. And capacitor are used in like a lot and many of the electrical device. Next, the last one is a diode. Diode is a tiny part in electronic that let electricity flow in only one direction, like a one gate that it used to protect device and control the flow of the electricity in the device. Thank you very much.